Warm up for lesson 7-6. Let's take a look at graphing the logarithm that we did before. Remember that two numbers that you can use for your input is the number 1 and the base number as well. And remember, this is the question we ask. What is the exponent on 2 to get 1? And so the answer is 0, and that's what we put here. What is the exponent on 2? What is the exponent on this base? That gives you 2. 2 is your x, and that is 1. So I go ahead and graph 1, 0, and 2, 1, and this is the graph of log base 2 of x. Pause and try to do this problem, and here's the answer. Pause to try to do this problem, and here's the answer. Lesson 7-6, Common Logarithms. Objective: to solve exponential equations using common logarithms, evaluate logarithmic expressions using the change of base formula. Common logarithms are base 10. So base 10 logarithms are what we call common logarithms. And they are usually written without the 10. So log base 10 of x is usually written log of x. And then we just assume when we say log of x that we're talking about base 10. There is on our calculator a log key to evaluate common logs. So if you wanted to evaluate log 5, you would press log 5 and then press enter. Now let's take a look at the graph of our common log, and you can see over here at 5, the value of the log is less than 1, which is what we have right here, a number that's less than 1. Now if we want to find log 0.3, and 0.3 is right about here, and then the y-coordinate will be negative, which is what we get when we put it into the calculator. So how would you use your calculator? You go over here to press log right here, and then you would put 0.3, and then you would press enter, and that's how they're getting this value. Okay, let's go ahead and practice finding log base 7, but before we use our calculator, let's estimate the value. So here's log of x, this is the graph. There's going to be the point 1, 0, and then way out here is going to be the point 10, 1. And you can see over here at 7, right here, the answer is going to be a little shy of 1, little less than 1. So let's go ahead and put it in our calculator. We'll press log, and then we'll press 7, and then we press enter. And so our answer is approximately 0.8451. 0.8451. All right, let's go ahead and find log of 0.5. Now 0.5 is right here, so I can see my answer is going to be a negative number. Let's go ahead and press log 0.5, and then press enter, and it's negative 0.3010, negative 0.3010. We can see it's a negative value. Okay, let's go ahead and do log of 10, and what we're asking is, what is the exponent on 10? What is the exponent on 10 to get the number 10? So this answer is 1. What is the exponent on 10? What is the exponent on to get 1? And the answer is 0. And then over here, this is just an inverse operation. This is the log in base 10, 10 to the 5th power, so they undo each other, and the answer is 5. Pause to do the problem. And here is the answer. Pause to do the problem. And here is the answer. Let's go ahead and solve exponential equations using logarithms, and in this case we're going to be using the common logarithms. So what we want to do is we have this expression, and we're going to take log on each side. Now remember, this is base 10, this is the common log, and then we're going to be able to take x and bring it down. And this is just a number, and what we're going to do is, to get x by itself, we're going to divide by that number, and we're going to put this in the calculator, and we're going to get 2.1240 using the calculator. Now I want to show you how to solve this a different way without logs to prove to you that we are really getting the right answer. And the way to do that is to graph 4 to the x and to graph 19 and see where they meet. So I'm going to go over here and I'm going to go to y equal where I have already put 4 to the x power and I put 19. My window is, the only thing I've altered on the standard window is my y max goes to 25 because I have to see y equal to 19. Now I'm going to press graph. And here's the log expression, 4 to the x being graphed and y equal to 19 being graphed. And I want that solution. So I'm going to press second, calc, and then I want the intersection, which is 5. And that is one of the functions I want. I want that other function. And then I'm going to move a little closer to the intersection and press enter. And that point is 2.12, and then if we round it, it'll be 40. And that's what I got with a calculator using logs, and that's what I get in the calculator by just looking at the intersection. All right, let's go ahead and practice. We can solve these another way, but we're practicing with common logs. So I'm going to take log on this side, and I'm going to take the log on this side as well. So I'm going to take the log of 3vx equals log of 15. So I took log of both sides. Now I'm going to bring down the x because that's one of my properties. And log 3 is a number. Log of 15 is a number. I want to isolate x, so I'm going to divide both sides by log 3. Log 3. This reduces. And then I go ahead and put this in my calculator to get an approximation. And so I'm going to go over here and write second quit, and I'm going to clear. I'm going to write log 15 parentheses divided by log 3 parentheses, and then enter. And my answer is 2.4650. 2.4545 4650. 4650. Okay, in this case I'm going to do the same thing. I'm going to take the log, ordinary log on both sides, common log, and this is going to be 6 to the x and 42. I'm going to use one of my properties to bring the x down. And I want to get the x by itself, so I'm going to divide by the number that's being multiplied to it. And then I can go ahead and put it in my calculator and get a decimal. All right, let's go ahead and pause and see what you can do on this problem. And here's the answer. Now, the reason I say be careful is because these two answers, the first 3 digits are the same. So you have to be very careful to read your calculator well to make sure that it's going to be this answer. All right, the change of base formula allows you to write equivalent logarithmic expressions that have different bases. So let's take a look at this expression, a to the x equals n. And this is the log expression, log base a of n, and isolating the variable. So this and this are the same expression. Now I'm going to take log base b of both sides, and then I am going to bring the x down over here, and then I'm going to get x by itself by dividing, very much like what I was doing a few minutes ago. And remember what x is. X is this, log base a of n. So this log base a of n can be rewritten in a new base. It'll be the new base, log base, with the original number divided by the log of the new base of the old base. So that's what this is saying right here. It's saying if you want a new base, log base, if you want to change log base a of n, then it's going to be log of the new base of the original number, log base b of the new base of the old base, and that'll get you there. Okay, let's go ahead and give you an example on how to do this. we want to write this in terms of the common logarithms. Now, why do we want to do that? Because it's easier for us to use our calculator instead of us trying to find log base 3. And so we're going to use base 10, and I really don't have to put this 10 here, but it's just to make sure that you understand we're using common logarithms, and it's of the value and then divided by the common log of the old base. And then you put that in your calculator and you get that. So I want to change this log base 6 of 8. And so I'm going to take the log, and I'm not going to put 10 because I'm just using common logs, of the value, and then log of the old base. And you're going to put that in the calculator, and we're going to round to the nearest 10,000ths, which is 4 decimal places. Okay, go ahead and pause and see what you can do. And this is the answer.